tutorials for the holiday homework. On the last tutorial we looked at worked example 3 and we looked at solving this particular equation using a long division method. I'm going to show you an alternative approach. You certainly don't need both approaches. Particular equations may suit one method or another method, but it's maybe a shorter method in terms of factorising some of these longer polynomials. The method is really based on the fact that division and multiplication are opposite operations. When you first meet multiplication, you have probably done your times tables in a times table, which looks something like this, where you've got one row multiplied by one column, multiplication sign there, and you're looking to multiply every value across the top by every value down the side. Now what we can do here is we can take our linear factor of x minus 2 and we can place that down the side. What we know we'll get is some x squared term, some x term and some constant term. Now we know that from our original solution that if we have a cubic and we divide by a linear factor, we'll end up with a quadratic as our solution. So we can get the framework set up for this particular example here. X minus 2 times some lot of x squared, we don't know yet, and some x's and some constants will give you this particular answer. So rather than dividing that by that, we're looking at some sort of process where we're going to multiply through. So in terms of the worded explanation, that may seem a bit complex, but follow me here in terms of what we're actually going to be doing with this particular process. What I'm looking for is pick up the first coefficient. So I know that x times some lot of x squared will give me 3x cubed. So x times what will give me 3x cubed. So the first coefficient must be a 3. And we're up and running. So as soon as you get that first coefficient underway, you can then go back to a multiplication rather than a division. What we've got here now is a times table. We've got 3x squared times x, and we're looking at filling in the gaps in our table, which will give me the 3x cubed. So everything in the black writing in the table here is going to filter out to be that particular part of the multiplication. So again, division and multiplication are opposite operations. So what we're looking to do is create this particular polynomial inside the times table. Once we've got that, we now need to do the second part of the multiplication, which is 3x squared times minus 2, which gives you minus 6x squared. Now that's fine, except our equation doesn't have minus 6x squared. Our equation has minus 4x squared. So we just need to think about how we're going to adjust this to get to the desired result of minus 4x squared. So we've got minus 6x squared. We want minus 4x squared, so in actual fact we need to add in 2x squared. And that box will always go diagonally opposite in that corner there. Okay, so you've created the second part of the equation. So just like a long division of polynomials, there's going to be a multi-step process. So one may suit you, but you certainly have both techniques up your sleeve. Now what we're looking at here is, again, the same sort of process here. X times x must equal 2x squared. So what's the coefficient we're missing here? It must be 2. Okay, so now we've got the second part of it going. Again, we're going to multiply. So 2x times x is 2x squared. 2x times minus 2 is going to give you minus 4x. And we've finished the multiplication part. Now we need to check our answer. Minus 4x is not 5x, so we need to adjust. How do we adjust this? Well, we're at minus 4, we need to get up to minus 5, so we're going to have to add in 9x. So again, same process, add in the 9x. Now you're looking at x times what constant will give you plus 9x. And that's where our plus 9 will come into play. Multiply out, 9 times x is 9x, that's what we have. 9 times minus 2 is minus 18. Okay, minus 18 is not the number we have here, so we're going to have some sort of remainder. Minus 18, how do we adjust it to get to 7? We're going to have to add in 25. So what we're looking at here is a remainder of plus 25 after we finish the process. So all this work here tidies up to be our polynomial, with our linear factor down the side and our quadratic factor written up the top. So a little bit wordy, a little bit difficult to follow the first time around. Example number 4, if this is not working for you, by all means go back to the long division I'm going to show you one more of these and then we'll switch and we'll be flexible between the two methods. So here I have another linear factor into a cubic factor, so I expect to get a quadratic factor as my answer here. I can follow through the long division, or I can write my linear factor down the side. X plus 1 down the side, and at the top here I know I'm going to get some sort of x squared term. Some sort of x term and some sort of constant term. You can draw these grids as you go depending on the size of the polynomial, but this is what we're starting at. So get into the question, x times some lot of x squared must give me 2x cubed in this example here. So the coefficient of x squared is going to be 2. And that would be the first thing that falls out of the long division method anyway. You'd have 2x squared to start you going with that particular process. So multiply back through, and we'll have x times 2x squared, which will give me the 2x cubed term that exists in the polynomial. Finishing off the multiplication, we've got 1 times 2x squared gives me 2x squared. I now need to check to see if I've got it correct or if I need to adjust. 2x squared is not minus 4x squared, so I'm going to need to adjust. What do I need to adjust by? 2 needs to go down to minus 4, so I'm going to have to take away 6x squareds. And I'm underway again, repeating the process. So this time x times some lot of x will give me minus 6x squared, so that coefficient must be minus 6. Minus 6 is the coefficient of the x term. Multiply back, minus 6x times 1 will give me minus 6x. Okay, once I finish the multiplication, I need to check to see if it's equal to what's in the polynomial, which it's not. Minus 6 is not equal to plus 5, so I need to add. How much do I need to add? I need to add 11x to adjust for that. So 11x gets added on there. Next stage here, I need to work out what my constant is. So x times what gives me 11x. So my constant must be plus 11. I just need to check if I've got a remainder through the process. So I need to do 11 times x is 11x. 11 times 1 will be plus 11. Plus 11 is not the same as minus 6, so I need to adjust to find the remainder. How much do I need to adjust by? Well, 11 needs to be taken down to minus 6, so I'm going to have a remainder of negative 17. Alternative technique will find you the same answer, so answer here 2x squared minus 6x plus 11. You take your pick of which method suits you for those particular examples. Question 5, moving on, we've now got a more complex question. We need to fully factorise this question. And then in question 6, we use our factorisation to go ahead and solve the polynomial. Slight difference here, and I will show you once more the long division process because it does change slightly because we don't have an x squared term. But we're looking at fully factorising x cubed minus 31x minus 30. We need to think about our remainder theorem. So we need to actually choose some values. We can probably do a little bit better than guesswork, but we need to choose values that we think will evaluate the polynomial to be equal to 0. I'm seeing 31, I'm seeing 30, I'm thinking it's either 1 or negative 1. A little bit of trial and error in terms of the size of these values and the director numbers. P negative 1 is a pretty sensible choice. Negative 1 cubed is negative 1. Minus 31 times minus 1 is plus 31. Minus 30 will give you 0. Now if we put in x equals negative 1 and we get out 0, then x plus 1, remember that sign change. If minus 1 gives you 0, then x plus 1 is a factor, and that'll be our linear factor that starts us off with the process. So we can either do this division by long division, or if you're keen on this process, you can attempt this one using this particular method here. This one will factorise and give you no remainder after you do the division. Following the process through as we have before, how many times does x go into x cubed? Gives us x squared. Multiply back, subtract, repeat the process. There's the working there. Make sure you can do those. And again, not a bad idea to be able to check with both particular techniques and also in your CAS calculator using the factor command. Once we get this, we have our linear factor and our quadratic factor. Moving over to board 3 here, we now have x plus 1, x squared minus x minus 30. Acrostics, or just a simple knowledge that minus 6 times 5 will be those particular factors. So we've got 3 linear factors, nice whole numbers, and we can move on and actually solve the particular polynomial. I've reinforced the fact that this is a hence question. When you see the exam at the end of the year, quite often you'll have a hence question, which means you must use the information from the previous question to solve the required answer. Okay, so if it just said solve, you'd be free to use whatever technique you liked. Because it says hence, you must use information in the previous question. And we'll do a bit more of that through the year with these hence questions. Null factor law, either this factor, or that factor equals to 0. So we have x equals to minus 1, plus 6, or negative 5. A variety of ways to cross-check. We probably wouldn't be able to guess it. We may be able to guess these, but p negative 6 should equal 0, and p5 should equal 0 as well. And you can set that up with a simple definition of the polynomial on your CAS calculator and check that as well. Another alternative method is where we're heading with this particular part of the course to sketch fx, px, or just y equals x cubed minus 31, x minus 30. And because these are the solutions for x when y equals to 0, these will be x-intercept points as well. So a cubic with 3 x-intercepts doesn't always need to be 3 x-intercepts, but in this particular case we have the 3 x-intercepts that come from these 3 linear factors. Okay, that is all there is. A couple of techniques for division. Why are we doing division? So we can factorise. Why do we factorise? So we can solve. Why do we solve? So we can find intercepts. A must-know process that started in Unit 1 and 2 and obviously continues through for the first part of Unit 3. Okay, that is all. Next time we'll meet example number 7. Thank you.